Hi, this is Glenn Gross, and today I've been thinking about the principle of involution from Howard Hanson's book, Harmonic Materials of the Tempered Scale. And the principle of involution basically says that whatever interval goes up can be reversed. You can take the reflection of it and go down. So, for example, if we went up one from G to A, we could also go down one from G to F. And this sort of suggests that you could have a lot of exercises based on the involution. For example, well, since involution is actually based on symmetry, another idea that I find interesting is that when you look at the trumpet or cornet, you have three valves here, and there's a symmetry in the valves, so that if you let the line of symmetry be the second valve, then you have one fingering over here, like this one, can be the mirror image of this one. So, for example, we can come up with trumpet fingerings that give us a mirror image, such as this. And we could also do a similar thing where holding the second valve down. Well, I find it interesting that these fingerings are symmetrical if you draw a line of symmetry on the second valve, but they're also symmetrical on the staff in that the note either goes up and down or it goes down, and the reflection down is also known as the involution. So then from there, I'd like to ask the question, do you think there is a mathematical formula which would explain the involution based on the length of the tube? It might be a question for physics. Also, I'm intrigued by the following relationship, and that is that there is a formula that works to give you each interval, and I think I've got it fairly accurate what that formula is. So if you start with the fundamental, we'll call this the fundamental. And we know to get the octave, the frequency is twice the fundamental. Well, if you divide the octave into two equal parts, you get the tritone. And it turns out that the formula to give you the frequency of the tritone is the square root of 2 times the fundamental. So if the frequency of this note is x, then the frequency of this note is x times the square root of 2. Now if we were to move another tritone, we're going to get x times the square root of 2 times the square root of 2, or 2x, which gives you the octave. So there's our factor of 2 divided into two square roots. Now you can write the square root of 2 as 2 to the 1/2 power. And so therefore the exponent tells you what portion of the octave have you traversed. Well, I think it's interesting then to realize that you could multiply instead by 2 to the 1/2. You could multiply by 2 to the 1/3 power, or the cube root of 2. And then if you do it 3 times, you'll get the octave. Therefore, 2 to the 1/3 power is the factor that gives you the major third, or the augmented chord. And intriguingly, that's also a symmetrical fingering, symmetrical around the second valve. So if you take 2 to the 1/3 and multiply it by the fundamental, you get the major third. So if the frequency of this note is x, then the frequency of this is 2 to the 1/3 times x, or the cube root of 2 times x. Now if you go up another major third, you get this interval, which we call the minor sixth. That is the sum of two major thirds, talking about music, and that's actually a multiplier of 2 to the 2/3, or the cube root of 2 times 2, I believe it is. The cube root of 2 squared is what it is. So anyway, so then we get, if we do it a third time, we get our octave back, because 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3 is 2 to the 1/3 plus 1/3 plus 1/3 is 2, which gives our doubling of the frequency, which is what the ear hears as an octave. So if we have 2 to the 1/3 power, that means we've traversed 1/3 of the octave, and that's the major third, or the familiar augmented chord. Now, what do you think happens if we go 2 to the 1/4 power, or the 4th root of 2? Well, we're going to have to do the operation 4 times in order to get to the octave, and so therefore we have our familiar diminished 7th chord, and the interval's a minor third. We got our first minor third, our second one, our third one, and our fourth one. And by the time you've done 4 multiplications by 2 to the 1/4 power, so you've got 2 to the 1/4 times 2 to the 1/4 times 2 to the 1/4 times 2 to the 1/4, that's equal to 2 to the 1/4 plus 1/4 plus 1/4 plus 1/4 power, or 2 to the 1, which is 2, and that's how we get our octave back. So when you write 2 to the 1/4 power, what you've actually done is you've described the multiplier that you need in order to get from the fundamental to a major third. Then if we were to talk about 2 to the 1/6 power, that would mean that we have traversed 1/6 of the octave, or the whole step, which translates into the whole tone scale. So what's cool about that is that's 2 to the 1/6, and you repeat the operation 6 times, and you get your 2 back. 2 to the 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. All those exponents add up and give you your 1. So 2 to the 1/6 power is a whole step, and that's your multiplier times the fundamental. Now finally, 2 to the 1/12 power is your formula to get the half step. So if we start here, if this frequency is X, then the frequency of the half step above is 2 to the 1/12 power times the fundamental. So it's X times 2 to the 1/12. And you can see from the math that if you multiply by 2 to the 1/12 power 12 times, then you're going to get 2 to the 1/12 to the 12th power, or 2 to the 1, and that's how you get your octave back, which when projected across the octave, it gives you your chromatic scale. So I hope you've enjoyed this brief journey into connecting the physics of sound with the staff, and describing the scale, and how you get your various chords. Your tritone is 2 to the 1/2, or multiplied by the square root of 2. Your major third is 2 to the 1/3, or multiplied by the cube root of 2. Your minor third is 2 to the 1/4, or multiplied by the 4th root of 2. Your whole step is 2 to the 1/6, or multiplied by the 6th root of 2. And finally, your half step is 2 to the 1/12, or multiplied by the 12th root of 2. Well, I hope you enjoy this, and it's kind of been on my mind lately. I'm excited to have sort of figured this stuff out. If you have any questions, please do give me a call, and please watch this space for more videos. Thanks for watching, and have a great day.